Alright, so hello everyone. We're back up with day 3, even though UNL is closed down. Day 3 here, we're going to cover Advent of Code. Right after this, I'll be live streaming the final exam review. Both of these videos will be available on YouTube right afterwards, so you can watch them at your convenience since UNL is closed. I've already pulled it up here. Let's go ahead and take a look. So let's go ahead and skip some of the story. Even though they agree to cut the fabric, so they're cutting a fabric here, where they're working on a very large square piece of fabric, 1,000 inches on each side. Each elf has made a claim about which area of fabric would be ideal for Santa's suit. All claims have an ID that consists of a single rectangle with edges parallel to the edges of the fabric. So they're cutting rectangles out of a big giant rectangle. The number of so it contains the number of inches between the left edge of the fabric and the left edge of the rectangle, the number of inches between the top edge of the fabric and the top edge of the rectangle. So if we jump down here and look at the example, those two first numbers are basically an offset. You're going from the top left of the giant rectangle, and then it gets you down to over here. And then of course the width and the height of the rectangle in inches, excuse me. So a claim like ID 123 starts at 3, 2, that's the offset. So 1, 2, 3 over, and then 2 down, 1, 2 down, or yeah, 1, 2 down, and it starts right here. And it's going to be of size 5 by 4, so I assume that that's going to be, okay, so the width, then height. Okay, so 5 by 4, 4 down. The problem is that many of these claims overlap, causing 2 or more claims to cover part of the same area. For example, we've got this small input here of 3 different ones, and then they've drawn it what it looks like here. So one would be kind of like this. I don't have block selection mode here, but then 2 is up here, and then of course they intersect at these x's, these 4 x's. 3 over here is adjacent, it looks like, but it does not intersect. So if the elves are all proceed with their plans, none of them will have enough fabric. How many square inches of fabric are within 2 or more claims? So the way that I'm going to model this problem, and the way that it was designed, obviously, is to use a big giant two-dimensional matrix, two-dimensional array, and we can simulate it kind of like this, but instead of these numbers like claim 1, claim 2, claim 3, what I'm going to do is I'm going to go through all of the claims, drawing, not really drawing, but keeping track of all of the claims, and what I'm going to do is I'm going to keep a counter. So these will be 1, all these will be 1, but the x's will end up being 2, indicating that there are 2 or more claims that intersect at that rectangle. It is basically a rectangle intersection, finding all the rectangles that intersect. I do have my input up here. It is somewhat large, 1281. Looks like they are all contiguous. I hope they're all contiguous. Yep. 1281 records. But to start out, since this is getting more complicated than days 1 and days 2, what I'm going to do is I'm going to use this input right here as a test case. And in fact, I'm going to visualize it to make sure that I get the same output over here. Okay? But I do want to make sure that my file parsing is correct. So instead of using the input over here, what I'm going to do is I'm going to set up a test case first. All right, so new file. Today is day 3, part A. These are the input. This is the input, so I'll call this input test. Right, and there's my input. Okay, I'll go ahead and use the starter code or start from code from yesterday. Duplicate 3. Okay, get rid of that. Go ahead and get rid of this. Start from scratch. Actually, yeah, I'll go ahead and start from scratch here. First of all, I'm going to want to keep track of the big, large rectangle, and I'm going to want to make it an integer because I'm going to keep a count of the number of claims that have a claim on that square inch. So I'm just going to make it, let's see, how big is this one? 1, 2, 3, 4, 5, 6, 7, 8. 8 by, I assume 8. 1, 2, 3, 4, 8 by 8. Okay. So int n is equal to 8, right? And then set up. Eventually, this is going to have to be dynamic. Now, the actual full input is going to be 1,000 by 1,000, which is only 1 million, and 1 million times 4 bytes. That's only 4 bytes. I could do that through a static array, but that's getting really, really close to like that's half of the stack right there, probably. So I'm going to keep it dynamic here, even with this small example. I'll just call it array. All right. I'm setting up those that array of pointers to pointers, and then for each one, I is less than n, I plus plus, I will set up that row, the ith row. All right. There we go. Now, there is no guarantee on what's in there right now. So at the same time, after I set up the row, I'm going to want to go ahead and set up the counters, initialize them all to 0. Okay. And now I have set up my my big giant piece of fabric, which in this case is only 8. Before we do that, let me go ahead and I'm going to want to visualize this. So let's go ahead and write a function here that prints out the fabric with all the counters in it. So or let's go ahead and say print fabric. Right? And we'll assume that it's square, so we'll only give it one dimension. Visually, I don't want to see a lot of zeros. I want to make it look like this. So what I'm going to do is if it's a 0, I'll go ahead and print a period. So if ARR sub I, j is 0, I'll put a period, and just to space, it's not spaced out, so I'll go ahead and not include a space either. Now in the simple example, we're not going to have double-digit numbers. In the large example, we will, but we're not going to be able to visually look at that anyway, because there's over 1,200 data points there. It's going to be kind of meaningless, and it's way too large for a screen. I'd have to really zoom out or something. So this is really only intended to debug and get this the test case correct. And maybe it'll also help in the second phase. %d and AR sub I, j. Right? And then after that row, we'll need to go ahead and go down to the next row. Right? So let me go ahead and just print the fabric right now. Right? Before we do any of the rest of this stuff, let me go ahead and make sure that I've got, I won't get rid of that now in case I need some of that code. But desktop. Right. Let me go ahead and increase the size here. There we go. And that was 2018 day 3. Okay. Let's run it. And there's what the piece of fabric looks like before any claims have been made. It looks like this without all those claims in there already. Okay. So what I'm going to do now is I'm going to go ahead and take care of the file I/O. Okay. There I will reuse this. For now, it's going to be the test.txt. I'll read it in line by line. Let's go ahead and restore that. Chomping the end line character doesn't really matter today, so I'll go ahead and get rid of that. Let's remind ourselves what this looks like. In fact, I like to go ahead and take just one sample over here, one line, put it into a comment while I'm developing this stuff. Okay, so we've got basically a buffer that needs to be tokenized now. I don't. There's a lot of characters in here, so I'm going to go ahead and tokenize. I just want this one, the first number, the second number, the third number, the fourth number, and the fifth number. And probably I'm just going to ignore that first number, but just in case, I'll go ahead and keep it for the next phase here. I'm going to call this X offset, Y offset, and then height and width. So I could call them just X, Y, W, and H. All right. And I'm thinking that on each iteration here, I'm going to go ahead and call a function that I'm going to build later to actually lay down the claim on the fabric. Just for now, I want to make sure that I'm getting all of the tokens correct. So no string copy here. No harm in keeping I for now, even though we're not going to use it. Maybe we'll need it in the second phase. All right, so I'm going to go ahead and start tokenizing. Str tok, and we'll need to capture that char star tok, because I've already used T. We're going to tokenize the buffer, right? And what our delimiters are going to be here? Well, I don't want that hash, I don't want that space, I don't want that that @ sign, I don't want a comma, I don't want a colon, and I don't want that X, right? So all of those will be treated as delimiters, and when we go through this and tokenize this, we're only going to get the things that are numbers. These 5 numbers right here, okay? So the first one is an ID. We can go ahead and ignore it and go ahead and call str tok again. If you want to, we can go ahead and int ID is equal to a to I tok. Oops, there we go. And then we'll go ahead and print it out just as a sanity check here to make sure that it works. %d, 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 and a line. And that's going to be ID, X, Y, W, and H. Right? Just make sure that I'm correct here. Left side, yeah, so that's X and Y. Okay. It makes sense, that's in order. Okay. So I'll go ahead and get the next token here. That is, we're going to pass in null on subsequent calls, but the same delimiters. In fact, I don't want to have to cut and paste that, so let me go over up here and create a string. Delims. Oops, too many colon or double quotes there. There we go. And now I can reuse this delims over here. Right. So the second token is going to be X, and then Y, width, and height. Was the width and the height correct? Width and then height, yep. So Y, width, and height. And then we'll go ahead and print it out to make sure that we're actually parsing this file correctly before we move on with the rest of the process, right? So 11344, let me go ahead and go over to the test input here. 11344, 231, let me go ahead and superimpose these. 23144, 35522. So I'm fairly confident that, that this is correct. All right, I'll go ahead and, for now, just comment out that print statement. So at this point, let's go ahead and get rid of all this because we're done with it. So at this point, what we need to do is we need to lay a claim to the specified part of the fabric, right? So I'm going to go ahead and just do this as a function, lay claim to the array of X, Y, W, and H, right? All right. And it's going to be a void function. Right now I'm not doing any error checking. I'm just going to assume that their input is valid, that X and Y don't go beyond, or X, Y, and then with a combination of WH don't go beyond the fabric. I know that for sure for the input, because, or not that input, but I know that for sure for the test input because of that visualization that we saw. So this is kind of the thinking part here, right? So if I've got 1, 3, right? So that's over 1. So if you think about this as a like I said, this is going to be an offset. 1 and 3 here are offsets. So if it was right up against the butting up right against the edge of the fabric, you'd have a 0, right? And that's why they probably designed it like this, so that you could use something familiar. You weren't off by 1, so I'm treating those as offsets. So starting from that offset 1, 3, and again it's from the top right, from 1, 3 down here, right? Then I'm going to draw, or I'm going to go ahead and iterate over this square. Again, I can't select it, I can't block select it, but I'm going to go over that square right there. So that should be actually a pretty easy loop, all right? I only need to, I'm going to borrow these two right here. It's going to be 2 loops, right? And instead of starting at 0, you're going to start at that offset. Instead of starting at 0 for j, you're going to start at that offset. And then instead of going up to n, you're going to go up to w and h, probably respectively. That's actually going to be a little bit, we're going to have to think about that, and let's go back to the example here to do that. So with this one, the width was 4. So if we start at an offset of 1, 1, 2, 3, 4, right? So that should go up to and including 5, right? Because, or 1, 2, 3, 4. So I think that by going strictly less than here, we're getting exactly what we want. Again, this is why I wrote the visualization, so you can actually verify that. And all I'm going to do is increment that counter. Okay. Let's go ahead and run this. Okay, AR, oops, sorry, didn't include my signature. Int, these are all integers. Right. And that's actually a pretty common design technique. If you have, so before I didn't have this. All right, I just put in a comment here of what I need to do. And what I thought, when I wrote this line right here, what I was thinking is, it would be nice if there was already a function here for me to use that could lay a claim to that array with these parameters, right? That dictated the design of the function. And so once I wrote what I wanted, then, well, okay, I'll just assume that I have that for now and I can use it and come back later, like the next step, and actually write it, okay? All right, so let's go ahead and print the fabric after this is all said and done. Oops, nope, I don't want to print the fabric on every iteration. Maybe as a debugging technique, if I need to, I can come back and print it on every iteration to see if it was correct. But I just want to look and see, shot in the dark here, was it, oh, and you know what, to make that look nicer, let's go ahead and put in a few more end-line characters. There we go. All right. There, so obviously it's not correct, right? I'm only getting 1, 1, 1. Okay, so now I will want to go back and go ahead. Let's go ahead and print each one on each iteration here to see as a hint to see what's actually going on here. Okay. So in the first iteration here, I'm only getting 1 column, right? That's a big hint right there. Let's go ahead and go back over here to my, okay, width, height, J++. I'm not seeing anything obviously wrong with it. Doesn't look like I've got anybody online right now. The first one should be starting at 1, 3. Right? So 1, 1. So it looks like and the second one only does 2. So, and then the third one, that's really weird that the third one doesn't print those end-line characters. All right, so let's see. go ahead and make sure that we're getting the correct inputs here. And of course, there's no ID anymore. X, Y, and Z, right? Let's go back up here. So we're getting 1, 3, and 4, 4, right? So if I initialize X and Y to 1 and 3, X, Y, and then, oh, you know what? It's an offset, and if we want to do a width, then we need to go from the start of the offset to the width or the height, respectively. All right. Let's go ahead and see if that makes a difference. The problem was we started at 1, or we started at 3, and we only went to 4, so that's why we were only giving that one column. I'm sure that there's still an issue here, but we'll see. Oh, hey. Nope. That's so now remember, these numbers are not going to be the same. My numbers are the counts of how many claims have been laid on that thing, and their numbers are the IDs. So down here, these 4 ones, that corresponds to these 3 over here. 1, 1, and then these 2s correspond to the X's where they actually overlap. Okay. I'm going to go ahead and get rid of the print statements. Oh, that's why I was putting it in there instead of where I should have put it in the print fabric. So I'm going to go ahead and get rid of these print statements. Print fabric, lay claim, and then I'm going to go ahead and change this to 1000 by 1000. And I'm going to go ahead and create, I guess I never got my input, so new file, 2018-03 input.txt. So input.txt, and then I actually need my input here. There we go. 1084, and again, I'm going to assume that none of them are big enough that they fall off the edge. And if they did that to us, then so be it. So let me go ahead and run this. It's still not going to spit out the answer, because the answer is how many squares, 1-inch squares, actually overlap. But I want to make sure that it actually runs. Okay, it actually runs without any segmentation fault. So what we're going to do here as a last step, instead of printing it out, we're going to have to go over it, and I'm going to just borrow this again. And anything that has a count of 2 or greater, we're going to need to keep a counter. So if ARR sub I and J is greater than or equal to 2, then counter will be incremented. And then that's what we're actually going to want to print. Okay. Get rid of this, recompile, run it. Still some debugging stuff up there. Let's go ahead and try it. Cross your fingers with me. And yeah, we got the right answer in the first try here. Let's go ahead and go on to part 2 here. We're already about 20 minutes in, so hopefully this is not that much more of a difficult of an extension. If it is, and I get stuck, I'll probably go ahead and take a break and come back later today. Amidst the chaos, you notice that exactly one claim doesn't overlap by even a single square inch of the fabric with any other claim. If you can somehow draw attention to it, maybe the elves will be able to make Santa's suit after all. For example, in the claims above, only claim 3, is intact after all other claims are made. What is the ID of the only claim that doesn't overlap? Okay. So this is actually a pretty simple extension of it, because what you can think about is we've already built this counter. This 1000 by 1000 has a bunch of squares that are counters. All we need to do is iterate over them again, and then instead of drawing them, instead of incrementing them for another one, we need to look at that subsquare of the claim, and if they're all exactly 1, right, then they would all have to be 1 because of the previous time that we encountered this claim. If they're all exactly 1, that means that it doesn't intersect with anybody else. Okay. So what I'm going to do is I'm going to close my input file and cut and paste it again. Actually, no, sorry. Before we do this, I always like to keep a record of everything I do. So I'm going to do part B here in a different file. I don't want to go ahead and change everything else and then lose my original solution. Always be saving, right? Always be backing up. Better yet, use get and then commit to each one of these things. So what I've already got proven code here to read through the file. So let's go ahead and cut and paste that down here, quick and dirty. Again, if I were doing this, well, like with design in mind, what I would do is I would be saving off these lines, right? The offsets, the IDs, and the X and Y. In fact, you know what? Since this is a review, let's do it properly. It's also going to give us an opportunity here to play around with some structures, okay? So let me come up here and actually define a structure because we've got 5 pieces of data: ID, X and Y offsets, and then height and width. Whenever you have 2 or more pieces of data, that's a perfect opportunity for you to encapsulate them into one logical unit. And in C, that's going to be a structure. Type def, excuse me. And I'll call it fabric or claim. Yeah. And again, it has those 5 things: int ID, int X, int Y, int width, and int height. There we go. So now down here, what I'm going to do is I'm going to create an array of each one of those. So I think I called it claim. Right? Claims is equal to call to malloc. Right? And how many of them do you want? Well, in the actual input values here, we've got 1281. So I'm going to go ahead and say I'll just hard code that, right? Again, if you want to take it another step, you could process the file once, see how many records there actually are, and then process it again. Or you could do some dynamic, on the fly increases or something like that, or a linked list, which is something we'll cover in CS2. But this is good enough for now, right? So instead of, well, I'll go ahead and still hand these off. But I will also have claims of I. Now this is where my I comes in handy. Thank goodness I didn't delete it. Where claims of I dot ID is equal to ID. Claims of X is equal to X. Claims of Y is equal to Y. And claims of width is equal to width. And claims of I of H is equal to H. Okay. Now I'm really tempted to go back and actually rename these, refactor this so that it's width. You're not paying by the character anymore in C, right? 40 years ago there was justification for abbreviating everything. Now there's no longer that justification. Readability is far more important than saving a few bytes of space. But I'll go ahead and do it then. Width, height, right? Come back up here and change these: width, height. The only other thing that I would suggest for X and Y would be to call them what they are. They're not X's and Y's, they're X's offset and Y offset, right? And then ID, that's an okay abbreviation. Identification is, ID is universally understood. And there's no reason to go ahead and type out identification every single time. It's just an ID, okay? So with those refactors right there, let me go ahead and do this and this. All right, that looks good. Let's go ahead and compile this to make sure that it's still working, that I didn't screw anything up. Remember, it's B, okay. No compilation errors just yet. But and then what we could do is we could go back and refactor this so that instead of X, Y, H, it passes in a claim, right? Claim C. And then instead, we're not going to want to print anymore. And then it would be, as I've got it currently, it's passing it by value. So it's actually making a copy of that structure onto the program stack. And then if you've got a regular old structure, you use the dot operator. Okay. And C dot Y offset with a capital O. And H, it would be C dot height. Okay. What would it look like if instead of passing it by value, that's not that big of a deal with this structure. There are only 5 integers, 5 times 4, that's 20 bytes at most, or thereabout. It depends on the efficiency of whether or not it's going to allocate a little bit more memory, but it's at least 20 bytes. 20 bytes being copied onto the program stack every time you call this function. Alternatively, this is not going to be that big of a savings, but you could pass in a pointer instead. And the only difference as far as this function is concerned is your use of the arrow operator. Right? Whenever you've got a pointer to a structure, you use the arrow operator. Whenever you've got a regular old structure, you use the dot operator. Okay? Just make sure that this works. Right. Oops, X. Oh, sorry, I didn't do the X over here. And I didn't do the Y over here. There we go. And of course now that we've changed this so that it's passing in a claim by reference, then what we're going to have to do is we're going to have to move this call down here after we've created the claim, and then we're going to have to pass in the claim, the ith claim. Now this is a regular old structure, right? That we would be this would be appropriate if we had gone with that first iteration where we were passing by value, but now we're passing by reference. So we need to put an ampersand in front of it to get the memory address of the ith claim. Okay. Let's go ahead and see if we get the same answer here. This is kind of ad hoc regression testing. The answer is not changed. I hope 1.5. Yep. The answer is not changed, so we didn't break anything. We didn't break anything in our logic. We just refactored it so that we can use a structure instead of a bunch of disparate pieces of data. Okay. All right. So back to the actual problem at hand here. Instead of just review. Instead of counting them up, I'm going to go ahead and iterate over them again. Now I don't need to open the file again, right? Because I already saved them all off into claims. Claims 0 through claims of however many there are. I think that there was one. So now so let's go ahead and put this into num claims, right? So that I can use that down there. Right? So for each claim, we're going to want to see, does that claim intersect with the big giant fabric, where it's located on that big giant fabric. If they're all 1, then we know that it doesn't intersect with anybody else. Okay. So I'm going to probably be reusing some of this, right? Let's go ahead and just, like the design I did before, I'm going to assume that I've got this nice function to do it for me, right? If, I don't know, pure intersect of the array and claim sub I, I'm already making a decision here to pass it by reference. Then I'll say printf, and now here's where the ID comes in, right? Before I was just printing it and ignoring it. Now I'm actually storing it into a structure. I didn't know if I was going to need that later, but I kind of thought that I might. %d does not intersect. Right. And we'll go ahead and print out claims sub I, and then this is going to be a pointer because we put an ampersand in front of it. But this one is a regular old structure, so we use the dot operator, right? And I do need to write this function now, right? I'm keeping this code simple and holding off figuring out how to do the actual logic until I absolutely need to, okay? So exact same signature as above here. right? And I'm going to put it right next to this function here because I'm going to want to probably reuse that logic, right? So this for loop here is iterating, and instead of incrementing, we're going to want to check to see if all ARR sub I j is equal to 1, right? So here's the sub rectangle right here. If we ever encounter something that's not 1, say 2 or 3 or 4, that means that there are a bunch of other fabrics that are intersecting with it. We immediately know that that fabric, that claim intersects with another claim, and so we can immediately return 0. So I'm actually going to go with the opposite claim here. If ARR sub I j is greater than 1, then I will return false. It's not a pure intersection. It intersects with another claim, right? Otherwise, if you get done with all of that, you can return true. They were all 1. Now there is another case here. What if it happens to be 0? ARR sub I j. If it's 1, then we like that, right? If it's 0, then we screwed up somewhere. I'm actually going to put this code in here as a sanity check. How did we screw up? Why did we screw up? Because the first time we go through it and lay a claim to it, we increment it by at least 1. If the second time we go through it and we see that it was 0, that we never incremented it for some reason, then we know that there's a serious problem there. So this is going to be a sanity check on my part. Okay. Oops, it should be claims, and that looks like the only issue. Claims, there we go, and claims. There. The sanity check worked, and we got and thankfully we only got 1 answer. If we'd gotten 2 answers or no answers or 3 answers or something like that, I would highly suspect that we have a bug somewhere. But because we got 1 answer, I am confident that that's the correct one, and it is. So we're now up to 6 gold stars. Day 3 is over, and we will be doing day 4 tomorrow. But later today, since UNL is closed, I'll go ahead and live stream the final exam from last year. Sometime after lunch. I'm going to eat first, okay? So, as usual, have a good day and have a good Festivus.